Now, we're going to take a few minutes to talk about hoisting in more detail. To hoist means to lift or raise. And in JavaScript, the term hoisting refers to variable declarations using var and function declarations being hoisted or lifted to the top of the code. This term is used to illustrate what is happening. But as we learned in the discussion on execution context, there's no movement of these declarations to the top of the code. The JavaScript engine is not moving code around. The real magic happens during the creation phase of establishing an execution context. As we discussed during that phase, the code is scanned for var declarations and function declarations, and then those are added to the memory and can therefore be used before the execution phase, which is the second phase, actually encounters the code. So in the case of variables, we don't receive an error when we access them. The value assigned is undefined, and that happens in the creation phase, but no error is received. In the case of function declarations, we're able to execute those functions before the execution phase encounters their declaration. Okay, let's look at some more code to help reinforce that. All right, I've got my Visual Studio Code window small again. I'm going to open up the console here because I'm going to want to see what happens once we add some code to this app.js file. So first thing I'm going to do is set up a function declaration, sum. And basically all we're doing inside of this console.log, we're adding num1 to num2, and we're logging that to the console. So there is our function. Now down below it, we're going to declare num1 and set that equal to 10. And then num2, set that equal to 5. So using a comma to separate those and have a single var for both variables. Now the other thing we're going to do is I'm going to come up here, and this is where I'm going to call the function. All right. Now looking at that, what is going to happen? What is console.log going to print? I want you to think about that for just a second before we actually save this and have it loaded into the console. All right, let me save it and let's see what we get. We get NaN, not a number. Why do we get that? Okay, so let's walk through this whole creation phase and an execution phase and see what's going on here. So in the creation phase of setting up this context, we're scanning for function declarations. Here's one. So that's placed in memory, the whole function is. And also variable declarations. Well, here's num1 and num2 using var. And so we'll put those in memory and we'll assign them undefined. Then we get to phase 2 execution. The first thing we encounter is we invoke that function. So that function is invoked. It is added to the call stack and begins running the code. We get console.log. It goes to the memory heap for num1 and num2 so it can add them together. Right now they're both undefined. They are there so we don't get an error, but they're undefined. And so undefined plus undefined ends up being not a number. That's why we get NaN. And then down here finally they get a value placed in that memory location. Okay, let's change this up just a bit. So let me comment out this one. Then I'm going to come down here and call sum from here. Take a look at that. Is that going to change our results? Well, yes, it is. Because in the execution phase, these get assigned a value of 10 and 5 before we actually invoke the function. So let's save that and see what happens. So now we get 15. So this code is not relying on hoisting, and so we don't run into problems. Now, let's go back to our original setup. This time I'm going to change the declaration to let. Now, let and const, how do they affect what happens with these variables? Well, let me save it and let's find out. Here we go. We get uncaught reference error. Cannot access num1 before initialization. So it's specifically telling us that we cannot access these until they are initialized. So they need to be initialized here before we can access them. Now, during that creation phase, they can be established in memory, but they do not have an initialized value of undefined. Let and const do not receive undefined, unlike var, which receives undefined when they're first set up in memory. So one of the differences between let, const, and var. All right, now, before we move to the next topic, a little personal note from me about hoisting. Hoisting has caused what I feel is poor code structure, and I've seen this from experienced JavaScript developers, and I think it should be avoided. So let me show you what I mean by poor code structure. You're maybe going wrong writing code, and you go ahead and enter a call to a function that you know you're going to define, that you need to define, something like this. And then you go ahead and define it using a function declaration. And once you've set this up, there's no problem with it. It works fine. Guess if I'm going to call it multiply, I should multiply the numbers there. And there's no problem with that, because of course the creation phase will establish this in memory. So the function is there, and so when the execution phase encounters this, it can invoke that function. It's available to invoke, and it works fine. But in my opinion, this is not recommended. I believe to have good code structure, you should establish variables up top. You should always establish functions before you invoke them. That is just good code structure. And so I would recommend that. In fact, if this here were defined as a function expression instead of a function declaration, the code would simply fail. It wouldn't work. And that is a very good reason to avoid relying on hoisting. And let's move to the next topic and look at the difference between function declarations and function expressions.